Today we are going to discuss one very important concept from integration called as the integration by parts. Now you already know that the integration by parts, which is commonly known as the U into V rule in integration, is a very big formula. But we are going to study a simple technique to find U into V rule. Now remember people, this technique can be applied only for the three functions: algebraic, trigonometric and exponential. Now the most important thing you need to take care here is that algebraic function has to be present, and then you can either have a trigonometric function or an exponential function. If you see an example, see x raised to 4 into sin x. This contains x raised to 4, which is an algebraic function, and it contains a trigonometric function sin x. Take a look at the second example, x cube into e raised to 2x. It contains one algebraic function x cube, and the other one is exponential function e raised to 2x. So this particular technique is applicable only if you have an algebraic function and either one of the trigonometric or the exponential function. Do not apply this shortcut technique for any other product of the functions. It is applicable only and only if you have an algebraic function and followed by a trigonometric or an exponential function. Now let us try and understand how this technique is used. So I have taken this example, x raised to 4 into sin x. Observe carefully. Whose algebraic function? It's x raised to 4. So write x raised to 4. Make a table in which I have written the first term as x raised to 4. Now you are very much familiar for differentiating a particular function. If you take x raised to 4 and if I ask you the derivative of x raised to 4, it is very easy, 4x cube. I have written 4x cube here now. Again you differentiate 4x cube, the derivative of 4x cube, 4 is constant, x cube derivative is 3x square, so that gives me 12x square. Again keep on following, again find the derivative of 12x square, so the derivative of 12x square, 12 is constant, x square derivative is 2x, you get 24x. Again keep on finding the derivative of 24x, the answer is 24. Now if you go ahead, the derivative of 24 is going to be 0. So I'm going to stop at this particular place. So what I did here, I have taken x raised to 4. I have written it as it is in the first column, x raised to 4, and I have consequently got derivatives till I have reached a constant term. Because ahead of constant, the derivative is going to become 0. Now who's the next term? It is sin x. Now you tell me what is integration of sin x? It is minus cos x. So that is written in the first column itself. Now see the difference. When I have taken derivative, I did not start derivative from the very first step. But when I have taken integration, I started from the immediate first step itself. So the integration of sin x was how much? It was minus cos x. It is written here. Now what is integration of minus cos x? Minus is constant. Cos x integration is sin x. So I get minus sin x. What is integration of minus sin x? Minus is constant. Integration of sin x is minus cos x. And the previous minus one becomes plus cos x. I have done plus cos x. What is integration of cos x? It is only sin x. I have done sin x. What is integration of sin x? It is minus cos x. So I have to stop at this place because 24 was my last term. So here also I have obtained subsequent integrals of the function. In the previous row also I have obtained subsequent derivatives of the function. The only point you need to take care here is derivative did not start from the first step, but the integration started from the very first step. The next thing that you should be doing is simply put alternate plus and minus sign. See, that is what I have done. Put alternate plus and minus sign, and then you straight away multiply this entire column, multiply this entire column, multiply the column. So if you keep on multiplying this column, that's plus x raised to 4 into minus cos x. You get minus x raised to 4 cos x. Then there is minus 4x cube into minus sin x. That will give me plus 4x cube sin x. Then there is plus 12x square into plus cos x. You get 12x square cos x. Minus 24x sin x and plus 24 into minus cos x will give me minus 24 cos x. That is an easier way of integrating x raised to 4 into sin x. If you try to integrate this by the conventional formula, it is going to take a lot of steps. At least 4 number of times you will need to integrate this particular function. Let's develop this one more time. If I take the function x cube into e raised to 2x, if you observe whose algebraic function, it is x cube, so I will write x cube over here. I will keep on subsequently find the derivatives. Derivative of x cube is 3x square. Derivative of 3x square is 6x. Derivative of 6x is 6. I have reached at my constant term. If I go ahead, the derivative is going to become 0. So no point in going ahead. Stop at this particular place. Now tell me, what is the integration of e raised to 2x? The integration of e raised to 2x is e raised to 2x upon 2. Have you again noticed I have started the integration from the very first step, but the derivative was not started from the first step. So you always begin the integration from the very first step, but not the derivative. So now e raised to 2x upon 2, that is what I have got here. Find the integral of this term. 1 upon 2 is constant. Integration of e raised to 2x is going to be e raised to 2x upon 2, and the 1 upon 2 becomes e raised to x upon 4. Again, if you try to get the integration, you get e raised to 2x upon 8. That's my next step. Again, if you try to find the integration, it is e raised to 2x upon 2 into 8 becomes 16. Again, put alternate plus and minus sign, alternate plus and minus sign, and then simply multiply them column wise. So your answer is going to be plus x cube into e raised to 2x upon 2. See, that's plus x cube e raised to x upon 2. Then minus 3x square into e raised to x upon 4. So that becomes minus, then there is 3x square, then e raised to 2x upon 4. Then there is plus 6x into this e raised to 2x upon 8. So 6x e raised to 2x upon 8. 6 and 8 can be cancelled, 3 and 4, and minus 6 into e raised to 2x upon 16. Obviously, you should put plus c at the end. So people, I guess you have pretty well understood how this integration technique can be applied, but make sure that you do not apply it at any place. It is applicable only if you have an algebraic, a trigonometric, and an exponential function. Algebraic is a must function, and any one of the trigonometric and exponential function should come. Now this integration is to be used at many different places. When you go to higher semesters like Fourier series and other places, you will be using this particular technique very extensively. I hope you have understood this particular technique. Thank you very much.